Hello everyone, this is the fourth lecture, and as you can see it is devoted to extensions of the two-variable linear regression model. So today I will discuss some, let's say, additional features, additional possibilities of two-variable linear regression models. And on this slide, you can see the very quick overview of today's discussion. So I will start with something called regression through the origin, so regression without an intercept. Then I will proceed to standardized variables, followed by the discussion of various functional forms that exist in econometrics. And then I will end by discussing how we can choose a functional form. So regression through the origin. This is very simple regression. This is the regression without the intercept. So in this model, the intercept is equal to 0. And equation number 1, this is an example of such a regression. So as you can see, y is just a function of x. There is no beta 1, there is only a slope coefficient beta 2. And here you can see the example of such a regression. Right, as you can see, the regression line just starts at point 0, where y and x is equal to 0, and the slope of this line is beta 2. Now let's see how this regression is different from the regression with an intercept. So if you look into this table, into the second line, you will see that the formula for beta 2 is very much different, right? First of all, it is much shorter. The same for the coefficient of determination or goodness of fit. If you compare these two equations, I would say that the one without an intercept is again simpler. And here I've mentioned the difference between the two sets of formulas. So without an intercept, we use raw cross products, in a sense that this data is not adjusted using cross products. Right, the cross products, those are the averages in simple words, like in this case, right? R squared is estimated by dividing the difference between the estimated value of y and its mean value over the actual value of y over the mean value. In case of the model without intercept, this is not done. So once again, the main difference between the estimates for the model with an intercept and for the model without intercept is that when we estimate the model without an intercept, we use raw data, which means that we do not adjust it for using mean or cross products. And obviously there are some consequences of using raw data. So first of all, the sum of squared residuals need not be 0. And if you remember from the previous class, we discussed the normality assumption, and we said that the average of the error terms should be equal to 0. Unfortunately, this may no longer be the case, which means that the normality assumption is violated, is no longer met. Besides, the coefficient of determination or R squared can be negative, which should not be the case, right? Because I think 2 classes before I showed you that this coefficient always lies between 0 and 1, and it must be between 0 and 1. Therefore, actually, for the reason that it might be negative, some econometricians, some economists prefer not to report R squared when they estimate regression without an intercept. So therefore, because of these 2 special features, it is very much recommended to use the conventional intercept-present model, so the model with the intercept, unless there is a very strong a priori expectation, unless your theory dictates you that you should delete the intercept and proceed with the model without an intercept.